Hey, hi guys. Good morning. Let me start sharing my screen. Okay. Yeah. Today, freshly, let's get started with pig. So, what is pig? In simple terms, I can say it like pig is a layer on top of MapReduce framework. Okay. So far, uh, in our sessions, like we talked about, so what is the need for HDFS to store the large data sets? And what is the need for yarn to resource manage, and to what is the need for MapReduce, so to write the Java code uh, to divide your logic, and these jobs will be will be executed under the yarn framework. But we have seen how complex this MapReduce is. Like, even just to filter out a couple of columns and to get the basic max of a salary or something, even for that, we had to write minimum 100 lines of code. Okay. So with that complexity, Yahoo came up like another alternative which runs or which simplifies the complexity of MapReduce framework. So which is called as a PIG. And again, this is not an acronym. This is not an acronym. It is not having any full form. It's just a funny name given to this tool. Okay. So pig is just a funny name given to that. And here, pig abstracts the complexity of or abstraction layer on top of MapReduce. Okay. In simple terms, this reduces the complexity of MapReduce and it runs on top of MapReduce. Okay. So how we'll see in our slides. Okay. And this is also one another open source framework. And this is also called as a data flow language. Why we call this as data flow language, you will understand once we start executing the pig commands. Okay, so from a script. And same like your, and all other your MapReduce features holds good for Pig as well. Like platform for analyzing large sets of data, same as like your MR. And Pig Latin is used to express the queries and data manipulation operations in simple scripts. Okay, so that is the advantage with this. Okay, and Pig converts the scripts into a sequence of underlying MR jobs. So this point we'll see in the architecture. Okay, and Pig is used to process different file formats like, so you can process CSV files, you can process any tab separated files, you can process JSON files, you can process log files, you can process records from RDBMS, and it has connectivity with your Hive, it has connectivity with your HBase. So all the systems. Okay. Those are the basic features about Pig. Okay. So why Pig? Again, the same one single strongest reason is that it abstracts the complexity of your MapReduce. It reduces your coding efforts, increases programmer productivity, insulates the Hadoop complexity, and similar to SQL syntax, so programmers will feel easy to prefer Pig language than your MapReduce. Okay. So why we use for Pig? For example, this is a simple scenario. So here I have two Excel sheets. So one is the user's Excel sheet that is having a username as one field and age as another column. Okay. So I have two columns, username and age, in users.csv file. Okay. And another Excel sheet with usernames and URLs he used to visit. Okay. Okay. So here the pages.csv, the second file, contains this. So my challenge here, my problem statement here is that I have to get the top 5 sites names. Okay. So whichever the URLs that gets the highest number of page views and viewed by age group 18 to 25. If this is my requirement, if I have to do this in Pig, so don't worry about the syntax for now. I just load that file and filtered the age group and loaded the second file. And in that, I joined by username. And since I need to count the number of page views, I did these lines. Okay. So finally sorted, and I extracted the top 5. Now, so if you see here, I have max of 3, 4, 5, 6, 7, 8 lines of code. Whereas if I have to do the same problem in MapReduce, so this much of code I need to write. So this is a screenshot of that MapReduce program. So the major advantages are like just 1/20th lines of code, just the 100 100 lines of code, very easily you can do it in 5 to 10 lines of code in Pig. And obviously your development time will get reduced. Okay. And this is a higher level language over MapReduce, as you know. But in the backend, it submits the MapReduce jobs only. Okay. So some of the differences are like MapReduce provides powerful mechanism for parallel computation. MapReduce gives you more finer control than Pig, because Pig is a higher level language, and if you need any programming concepts, like this is more of like a SQL like syntax, so almost all the SQL kind of features you can achieve in Pig, whereas in MapReduce, so that you can achieve them, but it takes time. Okay. And when not to use Pig. Okay. So when your input data format is really nasty, in the sense videos and audios and photos, so those scenarios, Pig may not be best fit for choosing there. And when we need more fine-grained control on processing, like the for loops I was talking about, and Pig lacks control structures, so loops are not possible. And if-else conditions and case statements are also difficult. Like if-else conditions were not at all there, and case statements, so they got recently introduced in Pig 0.14 onwards. Okay. So coming to the Pig architecture, you write your Pig commands into a script that can be named as .pig or .any extension is fine for it. .pig is not mandatory, but as an industry standard or practice, as part of best practices, we write them as .pig files. Okay. So we write our commands into that. If we submit that file, if we execute that file, so that script will be submitted to your Pig engine. So in the Pig engine or the Pig driver will have mainly 4 components. Okay, so you have to, I mean, this is a very simple architecture. And if you understood this architecture, your Hive is more or less similar to this. Okay. So once you submit the Pig script, it will be directed to Pig engine. Inside Pig engine, there will be a parser component or parse phase, during which this Pig script will get parsed into different commands, and all those commands will be checked against the syntax errors in the compile phase. If there are no syntax errors, then the script will get compiled as a MapReduce jobs, and then in executing those MapReduce tasks, it identifies the optimized paths, optimized way. Okay, so by default, whatever the compiled code, Pig compiled code, gets optimized first, and it gets optimized, and then in the planning phase, so what are the map tasks and what are the reduced tasks it has to trigger, all those tasks will be finalized here. Okay, so this is the parse phase, and here the compilation of your Pig script will take place. and checks for all the syntax errors. If there are no syntax errors, it gets compiled appropriately. And then here the optimization of the script takes place. And in the plan, it gets converted into your map and reduce tasks, and in which sequence they have to run, it gets finalized in this plan. Okay, again here it will generate two types of plans. One is a logical plan and another one is a physical plan. So we'll see them slowly. So once this is converted into MapReduce tasks, so this MapReduce jobs will be submitted to your YARN framework, the resource manager. And resource manager, so from here onwards, we know that anatomy. Like resource manager will identify one application master, it identifies one node manager, and on that it launches the application master. And the application master reads in your input file sizes, and if it comes to know that it needs 10 maps and 5 reduced tasks, and again that application master sends request to resource manager, and this time resource manager sends the list of node managers, and on those node managers it will run those map tasks and reduce tasks, and those tasks will read in the HDFS and name node files via the name node master. They read in the HDFS data and they will process that, and they come back with the results and in the same sequence. So they come to the Pig engine, okay, and from Pig engine to end user. So now, so this is already an existing cluster that we already talked about. HDFS is for storage purpose, YARN is for resource management, and MapReduce jobs are for processing the data. Processing engine. Now, on top of this existing architecture, we have this as a one layer. And this is purely a client installation. You don't, let's assume if you have 20 node cluster, and on each 20 nodes, you should have the HDFS, HDFS in the sense, data node daemons, HDFS corresponding daemons needs to be running. So the data node will be running. And on all the 20 nodes, YARN framework services should be running, which is node manager. Okay. So this is anyway processing engine which gets submitted to here. But you don't have to install this Pig tool on all the 20 nodes. Just install it on a client machine. Installing it on a client machine is sufficient. This is in terms of admin concepts I'm telling. Okay. Because on the client, so from your client machine, you will have your MapReduce installed YARN setup and HDFS setup. So if you submit the Pig script, so on the client machine itself, the Pig engine will parse and it divides. It creates the plan for submitting the MapReduce job. Once it submits the MapReduce job, it is typical to any other, I mean, it is similar to any other typical MapReduce job. The way you submit your MapReduce job from your client machine. Okay, it is not like any other, the distributed architecture, or it is not having that much of architecture. This is just a tool at client machine, which takes the commands and compiles it and converts that into MapReduce job. And that MapReduce job will be submitted from your client machine to your resource manager. Okay, is this clear to everyone? Yes, Anand.
Still not clear. Like, what is the pig again for? Because we have MapReduce, but prior to MapReduce, what kind of things we would like to do?
Whatever the things that you can do almost in MapReduce job, so those stuff you can do in Pig with simple commands. Okay. So here you were writing in hundreds of lines of code. The same thing in a SQL kind of syntax. I mean, similar to SQL syntax, not the same SQL syntax. So using that commands, you can write maybe 5 to 10 commands here. If you submit that to Pig Engine in client machine, this converts them into MapReduce jobs.
So the arrow should be to the yarn framework, not to the MapReduce, right? Because pig output is already MapReduce.
Pig output, to yarn. Yeah, pig output submits the MapReduce jobs to yarn. Pig output is MapReduce jobs, right? And those jobs will be submitted to, or you can assume this way: the arrow should be to yarn resource manager, and on top of arrow you have MapReduce jobs.
Correct. That's exactly I was thinking.
My intention is that only here. Okay. Okay. It just abstracts the complexity of your MapReduce job. That's it. So instead of writing
much better, right?
What is it?
I think so. It's much better than the complex code, right? So
yep.
Pretty straightforward. That's pretty nice.
And because of writing less code, the other advantages are like your readability by programmers, easily understandable, and development efforts get reduced. Also, once it goes to live, maintenance cost will get reduced, obviously, right? If you have hundreds of lines of code, if something goes wrong in 67th line, it obviously takes to debug and fix them, and there is a lot of cycle. If only 4 or 5 lines of code, again the maintenance cost will be less.
So Pig seems to be very popular, right?
Yep, Pig seems to be very popular, but the sequence that I follow will make you always forget about the previous tool. So now here, what am I telling now? So Pig is better than MapReduce. Try to do everything in Pig as much as you can, as much as Pig can. Okay. And if you can't do in Pig, then go for MapReduce. So this is what my statement for today. Right? You are getting that gist at least.
Yes, yes.
This holds good till Pig completion, till whatever you know till today.
That's pretty cool. Okay.
Yep. Okay. Yep. So this is always like going higher level. You have assembler language. After that, C language came. Okay. After that, C++ came. After that, Java came. So after that, Scala came. So Scala, if you know assembler language, you can code anything, obviously. Okay. And if you know C, you obviously will not prefer to go with assembler. But if you can't achieve anything in C, you have to go into the low-level language, then you have to control that. Because anything that you write in C or Java, obviously they are going to work through the assembler kind of language. They maintain the registers kind of stuff to maintain the variables and all that stuff. So the low-level language is the base or foundation for the higher level languages. Okay. So once you know the Java, and then if you go to Scala, obviously you will not like coding in Java. Let me move on. So that's the funda behind that, the low level to high level language migrations. Okay. So now how can you start your pig shells here? Okay. So pig can be run in local mode and as well as in cluster mode, same like your MapReduce. Local mode, how we run it in the Eclipse for uh, inside the Eclipse for MapReduce. So here, pig local mode and MapReduce mode, both of them you can run it from the terminal. Okay. So to specify that execution mode, we have -X option. Here you specify either local or MapReduce. Okay. So I don't recommend you to do any practicing in local because that will not solve you. I mean, that will not help you anything in real time. So I would recommend you to directly practice in the MapReduce mode only. Okay. So MapReduce mode can act on the HDFS files, whereas your local mode can read in your local files as well. Okay, so let me run into this pig shell. You just give me a second. I'm getting some background noise here. Okay, yeah, sorry guys. Yeah, I was getting some background noise here. Okay. So, in order to enter into your pig shell, this is like this looks like interpreter kind of language where you can run your commands from the terminal itself. Whereas in pig, we don't have that. Whereas in MapReduce, we don't have that facility. So we had to write in a Java file and compile that and build a jar and to do all that stuff. But with Pig Engine, you don't need to do that. Just start into Pig shell, keep typing on your commands and executing them there itself. Okay, it looks like a Python or any other a Perl or kind of interpreter kind of languages. So if you see, if you observe the basic info messages here, so Apache Pig version, I have, this is my 5.4 VM. So I have Pig 0.12 or so. Okay. So Pig, one of the things that you observe, Pig produces lots and lots of info messages onto your terminal. Okay. So you can see, you can observe, this is the Pig version, and it logs in your error messages to this folder. By default, whichever the username it corresponds to, from that username you logged into the Pig shell. So in that home directory, since I logged in with Cloudera, so in my Cloudera home directory, I have this pig underscore this is the timestamp, which is in epoch format .log file. Okay, so you can see this log file being written at this home directory.
How can you change this path for changing the log file?
Good question. I was about to say that. Okay. Yeah, this is again an admin stuff. If you want to change that path, any configuration changes at cluster level, so the edge node level, that admin will take care. But anyway, let me show you that properly. You can see that the log file got generated here. I think it's 76919, right? 76. So there are no error messages as of now in that. That's why the file is not yet created. Okay. So this is called a lazy mode of creation of your files. Unless until there is no content for that file, the file will not get created. So far there are no errors. So this is an example already existing file. Okay, this is for your debugging purpose of your. You can see the error log messages here. Now, if you want to control the change of these paths, obviously the location is your configurations folders, right? So they will be present in /etc. For pig, you need to look for pig folder and go to conf and your pig.properties. Go to pig.properties. Here you can configure the pig related stuff and anything related to logging. So you have to control that in the log4j.properties file. Okay. Okay. So here log4j pig info, all info level messages will get printed. Okay. And a set to the console appender, and here again this somewhere you will have this file name to be generated, the pattern also, conversion pattern layout. I think it's not there. Okay. So execution type MapReduce, default one, log file. If we don't set up the any path here, generally this is the place where we set up the path for log file. If we don't any path here, by default, the home directory is the assumed one. Okay. So you can play around these properties. So yeah, and next, if you observe some of these properties, instead of it is connecting to, in MapReduce mode, by default it's connecting to Hadoop file system, which is running at hdfs://quickstart.cloudera8020. And similarly, it's connecting to MapReduce job tracker. So it's showing those error messages, I mean those info messages as per the old one, MRV1, where you have job tracker and task tracker. Okay. but it's not connecting to that. Those messages needs to get fixed from the pig framework. Okay, so some of the properties it read from all the configurations, Hadoop configurations. Okay, so this is your pig shell now. Control L will clear the screen. Now let's go one by one. So here in pig, you have mainly two components that we call. So one is the pig Latin, the language we use for writing our commands, and pig engine, which is the execution environment. Okay, that execution environment is having mainly 2 to 3 types. So one is local mode of execution, and another one is MapReduce mode, and there is one more called Tej mode of execution thing. But that is available only in Hortonworks Hadoop platform only, Tej. Okay, so the way we have Impala in Cloudera, specific to Cloudera, that got developed from Cloudera's community. Hortonworks community developed the Tej engine. Okay, so which is similar to your MapReduce, but at least it runs 2 to 4 times faster than your MapReduce jobs. In case if your MapReduce job is taking 10 minutes, your Tej, the same job, that Tej, if you write in Tej framework, so it will get completed either in 5 minutes or even lesser than that. But 2 times faster is guaranteed. Okay. But instead of learning that Tej framework to write the jobs completely there, the way we can convert our pig commands to MapReduce jobs using the pig engine. Obviously, we can use the same technique for converting your pig commands into Tej jobs as well. That is one advantage with Hortonworks. So with that, in Hortonworks, no one uses the MapReduce engine in the backend of pig. They always use Tej because it gives a minimum guarantee of double the speed. But you can see sometimes up to 4 times, 6 times also. And by now, I mean, I was using that Hortonworks almost 1.5 years ago. So by now they might have improved it even more better. Okay. Now, inside your pig shell, just to explore what are the commands that you can see. So use the list command. But anyway, let's get started with. So in order to process any data, first we need to load the data into pig or read the data from your HDFS. Okay, so for reading the data, so we need to go for some load store functions. Load and store functions. That load store functions are responsible for loading your data set from your HDFS. And once you load that, once you are done with the processing of the data set, again, similar kind of store functions by using there, you can store them back to your HDFS. Okay, so this is like your file is present in HDFS. From there, you are loading into pig's temporary workspace, pig engine's temporary workspace. There you are keeping that file for some time and process the data and finally store that results back to your HDFS. Write your results back to your HDFS. So in between load and store, you will apply some transformations. Assume you loaded a file with 20 fields, comma separated, 20 columns, and you filtered out 15 columns, now left with only 5 columns. And you filtered out some records also with bad values. Now, in your input file, you had 1,000 lines. Now you have only 50 lines with 5 columns. And that transformations will take place between the load and store. And finally, the store command will be invoked to save your results back. Okay. So here, again, to load your data sets or your files, so based on the file formats, we have different load storers. Here, so there are some functions which can act as both. The same function can be used for load and as well as store. Okay. So if you use a set of parameters, it's associated another operators, it decides whether to load it or store it. Okay, so one such load store function is pig storage. This can load any type of text files, any formatted text files, and you can store your results back to your HDFS. Okay, and if you have to deal with some kind of so if there is no schema, then we have another option of text loader also, but this is not popular, or this is not being widely used, because by providing if you skip the schema here, pig storage, almost it solves all the purposes of your text loader as well. And if you have any JSON file to load, you can use the JSON loader. And if you have any other file formats, like I was talking about, like sequence file, RC files, those things, so you have corresponding load storers for them, even for those file formats. Okay, but now let's limit our scope to only a few load storers. Okay, slowly you will understand where to learn them perfectly. Okay, so instead of we spending lots of time here. Okay, but since Hadoop ecosystem is it's a family of so many open source tools, you should be aware of all the tools. Okay, so now for your practicing, I have actually created one input folder with set of input files and scripts as well. Let me give that to your practicing. Yeah, so this is the data that I have for you. So this pig example sample data, I will copy it for you into the project. Let me copy this for your practicing. Okay, So now let me load these files into, since I'm not practicing and I'm not recommending you to do it in local mode practicing. So let's load these files into HDFS first to play with them. So right click, new tab, Hadoop FS -ls. So it might be present in my Cloudera. Yeah, is it the same case with everyone that your VMs are responding very slow, or sometimes it gives me quickly results, but sometimes it takes time. Even for ls command, it should not take this much of time. Okay, at least examples. Oh, this data, I think that folder only. Okay. Yes. These files I have already uploaded to HDFS. So I have this file. If I have to read this file, yes, I will take this file path in grunt shell. Okay. So if I load anything, I should assign that to some variable, or we call it as a relation, or we call it as a schema in big terminologies. So we have to assign that into some variable, some a equal to load txt using the big storage. What is the delimiter that I have in this file? So if you see here, it's comma separated. Okay. So I can specify the delimiter here. Okay. And if I have any schema, like if I want to name these as columns, same like your pig syntax, you can specify same like your SQL syntax, as and specify f1 colon int and f2 field 2 colon int and f3 colon int. So this load statement got captured by your pig engine, but not yet executed. So all your pig commands will get executed only when they encounter either dump command or store command. Dump is to show your results on the console, on this terminal, on this pig terminal. That is only for testing purpose. And in real time, we'll store those results into your file. Okay. So only when you need to view the results, or when you need to store those results, then only the execution of all your previous commands will start. Until then, your pig engine will keep on capturing those commands. That's it. It will not execute them. Okay. So now, so if I have to view the results of this relation A, bag A, then I can type, so dump A. Now it started submitting the MapReduce job. So if you observe here, so big features used in the script, and these are some kind of optimizers that are taken place, and MR plan size after optimization, that is 1. So how many plans that are there in the MR after optimizing it? And if you come here, big script settings are added to job, and it's somewhere you can see that this is being submitted as a MapReduce job. Even for viewing just the file contents as it is, see here you can see connecting to resource manager on 8032, and so how many from here onwards these messages are similar to your MapReduce. Like, so total input paths to process 1, there is only one file that I gave. Okay, so it is processing for aliases A. I have only one alias or one relation, one bag. We call that variable name. Okay. So MapReduce launcher 0% completed. This is the job that here again, since these get submitted to Yarn, you can view these jobs also in Yarn Resource Manager web UI. Okay. So you can view them.
Siva, what is the correlation of pig with yarn? How does pig invokes yarn?
How does I think that's more of like a admin kind of stuff. You are interested in that, like the configuration properties. So we'll specify that it will points to that on that same cluster. It looks for the yarn home directories or yarn conf directories, and it identifies the properties in which port number and in which host name your yarn resource manager is running. Then it connects to that to submit the MapReduce job.
Oh, okay. So that has to be configured.
Yep. I mean, we don't really, that's not a job of our developers, that the admin will.
Yes. And then this pig job will be automatically, the results will be automatically written to HDFS.
If you dump, they will be shown on your console. If you store, they will be stored into your HDFS.
Okay.
Shiva, is
Yep.
it like when pig is executed, pig script is executed, so this will convert it to MapReduce job, right?
Oh, I didn't get your question. Your voice is very low, Satish.
No, like I mean to say when pig script is executed, so this will convert into MapReduce job.
Correct.
So is there any way we can see where this MapReduce job is being
Converted?
Yeah.
That happens in the pig engine. That is abstracted. You can only see what are the steps that gets involved and what are the how many jobs it is getting submitted. Okay. So my machine is very slow, so please bear with it. It's almost like getting hanged or something. Let me close some applications and I will kill some of the services so that it will not eat up our time.
Sure.
Yeah, Murli.
See, actually, in grunt we given you some command, right? A equal to something path. Using pig storage comma, after that we given as
Yep, as
F1 equal
the schema.
I mean, fn colon int. What is the meaning that I'm like we are mapping to the what that particular field to the this type
Yep.
or
Same like your SQL syntax. How will you write this in SQL? Create table, table name, and inside parenthesis, you'll specify the column name and its data type, right?
yeah.
Column name space data type. But here I specified the column name colon data type. That's it. That's the only difference.
Something like suppose it is a student table. First one is the student ID colon int.
Yes.
Something like
ID, integer, name, string, and here we don't have string. We have some char array. Okay. So it's corresponding data types. So I just took the basic example. Anyway, I will be going through the data types and those slides as well again. Okay. So for the first initial data set, it's please bear with me. This is very damn slow. It's not responding. Okay. So yeah, let that get executed. That displays only the contents on the console. Anyway, once that comes up, I will show you that. So let's not wait for that. So when I say dump the dataset name, so that prints all your contents onto the console. We'll see them. So instead of printing them onto the console, if you want to store those results into some location on HDFS. Of course, here we didn't do any transformation. So simply loaded that file. And in real time, obviously, before you store, you will do some transformation. Then only it makes sense to store it back. Otherwise, what is the need for storing the same? Okay, you already have. And similar to load, a lot of options are available here. You can store locally or in HDFS. And we can write our own custom storage classes as well. Okay, so but let's not worry that now. So here to store any alias or relation into, so now I loaded the data into A equal to load and path using pig storage and specify the delimiter and then take that, right? Now, if you want to load that relation back to your HDFS, if you want to store that relation back to your HDFS, you can use some example command like store space your store followed by your relation name into, so this time into the path in which you want to store, and this output directory location, it should not be present because this is like providing output location to your MapReduce job. If it is already present, then it will throw an error message saying that this is present. This directory already exists. Using pig storage, again here you can specify what is the delimiter that you want to use between your fields. Okay, so this is optional or you can specify, so whatever the delimiter that you are interested in. Okay, so if I load that input data using the comma separated, and if I want to store them as a tab delimited, yes, I can do this. Load dataset using this pig storage comma in single quotes comma, and when I am storing those results back into HDFS, I can specify the delimiter as pipe. Let me see whether this job is. So unexpected error during execution. So only 50% is completed. So it was not able to print those contents. So let's see what is the error message, whether I gave any wrong messages, or you can see this 76919 in your home directory. Go to your home. So you can see the 4th file got created here. Let's see the error message. Good that we got at least one error message. Okay. So unable to open iterator for alias A. Unable to store alias A. Unexpected error during. Enum, no enum constant, MB millis maps. Something wrong with your pig execution itself. Okay. So this is execution engine exception only. Expected error. This shouldn't be. If I have given any syntax errors, then it should throw me those errors. So this unable to store alias A, execution exception. So no enum constant. Let me.
Shiva, I have a doubt right now. See, now successfully one time it's assume like it's a successfully run the command. A is the data is stored in A. Okay. Suppose once again I want to run any other command, any other file to store in A. It is possible.
Yes, it's like overriding your variable.
That's it.
Yes.
Okay. Thanks.
Okay. Yeah. Let me recheck this one. If it doesn't work, we'll move on to some different VM, because let's not waste our time in debugging those admin stuff. Okay. I will try to fix that in the offline, or I will move on to different machine. You can launch, if you don't provide your execution engine like pig -x MapReduce or local. If you don't give this -x option at all, then by default it will enter into MapReduce mode only. Okay. So let me give one chance, one last try. If this is not working out, because I'm not doing much stuff here. Okay. So I'm just loading and trying to print those results here. So that is for load and store. Next, let's enter into the pig Latin language. Okay. So now here we can discuss the data types. So pig basic data types that comes, like here we have primary data types and complex data types. So these are like basic. So int and long are for integers, and float and double for decimals, and boolean for true or false, and char array for strings. We don't have string data type in pig. We have char array. Okay. And if you don't specify any data type to a column, then its default data type is byte array. It's an array of bytes. Okay. How will column heading handled while loading and storing? Column heading handled. Column, see, once you loaded the data set into your grunt shell, there if you want to play with your column names, then only they will be useful. Otherwise, once you store your results, your headers will not come into picture. Okay, so those heading names. So Shiva, can you show me the load command once? I will try from my end and see whether I'm getting the same error. Okay, load command syntax is same. Okay, so this is load, and give any of your HDFS file path. HDFS path using pig storage. Using pig storage, don't give any delimiters. So So till here itself is also fine. Okay. If you don't give any delimiters, then entire one line is treated as one field. That's it. Entire line is treated as one field, even if you have multiple fields there. Okay. And if you don't give this schema, as I told you, based on the delimiters, so if it belongs to only one line, then it will be treated as one field, which is of like a string type or byte array type. Okay. Let me see. So this is my. So in this case, I want this file to be read by comma delimited. It loads into 3 fields, but I didn't give those field names or those data types. So by default, it has the positional notation to access those fields. It still will have 3 fields, like $0 for first field and $1 for second field and $2 for third field. And the data types by default it assumes is byte arrays. Okay, so in order to check the syntax or the schema, this describe command, keep this command in handy. In this command is available in Pig, it's available in Hive, it's available in Impala, it's available in HBase also. And its purpose is same across all these 4 tools: to view the schema, to view the layout. Describe A, schema for A is unknown. If I define this way, because I didn't specify the schema there, F1, or you want some ID, if it is int, and let's assume second column is age, which is int, and third column is department ID. Okay, which is of int. Again, this gets overridden. Now, if you see, describe A prints me the schema. So it tells me that A is of this is for ID is for column name, and int its data type age column, and int data type, and department ID column int data type. It prints that schema. Now let's load dump A. Okay. Let me see if there are all services running or not. Job history server is also running. History server is running. And resource manager is running. Node manager is running. Name node.
Shiva, I've run the same command and it's working for me fine.
Yeah. So this is, so as I told you, I mean, it might be some configuration. I might be changing some of the properties here and there to showcase sometimes in the trainings, right? So that times it might get failed. Okay. So it's something error that I produced by incorrect configurations. Let me deal with this later. Okay. I will close this. I will suspend this, and I will start the Cloudera Quick Start VM 5.5. Okay. So I have at least 3 to 4 VM instances available always in my hand. Always. Okay, we can practice in. Okay, so let that get loaded. That gets loaded. So meanwhile, let's discuss. Okay. So we talked about how to load and we have seen that syntax, load path using storage. Here, coming to the case sensitivity of these syntaxes. So anything that you see, the pig operators like load, using, all these keywords are case insensitive. Okay. So this can be capitals, this can be capitals or lowercase as well. But when you observe the function names like these, the pig storage, when you see these are like your Java class names, right? The camel case. The first letter of every word is an uppercase. Then, so it is a case sensitive. You can't specify this way, pig storage, then it will throw an error message that class not found for this. Okay. So when you have camel case, then it is case sensitive. So if you don't have any camel case in your syntaxes, whenever I type. So basic funda is functions. So this is like when it expects a parenthesis, that is nothing but a function. So if it is simply a keyword, then those are case insensitive. You can either write them in uppercase or lowercase, no matter. Okay. So when if it is expecting any parenthesis, that means this is acts like a function, load store function, then that is a case sensitive. Okay, so we have seen this. So here the various versions are like, if you specify the big storage, by default, if you don't specify any delimiters, the entire line will be one field, and even specifying the schema is again optional. But if you want to specify the schema, you can specify with as class. Okay, and we have seen dump command, and dump followed by alias. Okay, and we have seen store alias name into the path using pig storage. So this time, what is the delimiter that you want to specify? You can specify that. Okay. So now coming to the data types, we have listed down same like your Java data types: int, long, float, double. Only difference that you see for strings, we have char array here. And by default, if you don't specify any data type, let's say if I give here as f1, comma f2, comma f3, I didn't specify the data types. Then here the data types for f1 and f2 and f3 will become the byte array. Okay. So when we do not specify schema, why describe not showing default schema instead of unknown schema? So as you explicitly didn't specify any schema for that, so by default it shows you that way. Okay. If you don't specify the data types, but if you specify the column names, then it shows this way: f1, f2, and f3. If there are no column names and no data types defined by you, so you can still access those column names by $0, $1, $2 like that, but those are the internal to pick that will not be displayed by your describe. Okay. This is taking even more longer time to open itself.
Siva, what processor you have? i5 or i7?
i5.
Oh, with i5 you have 4 or 5 VMs?
Not all parallelly running, right?
Okay, I was like, that's pretty amazing.
One or two.
Okay.
Yeah, I will suspend one and start the another one. Okay. So till data types we are okay. Now we have some complex data types also. So complex data types we have mainly three. So tuples and bag and map. Tuple, I mean, there are few guys who attended my Scala sessions as well. The tuples in Scala and tuples in Pig more or less the same. Okay. Is number of values separated with some delimiter present in the file is equal to the field definition provided in the, yes, obviously the same number of fields that we need to specify there. See, this is like, and yeah, since you are from Java background, this area will be something like you will start it for freshly, and you need some time to understand this model. Okay, so you can write all those MapReduce programs. Coming to the tables and the columns kind of stuff, yeah, you will kind of like you need to think from the basic. Okay, so those are like columns, right? If I have shown you that file. This is having three comma separated columns there. It's like a basic table set. Okay. Let this. Okay. So yeah, coming to the tuples, it's the same. I mean, whoever knows that Scala, the tuples in Pig are similar to the tuples in Scala. Okay. So, but for others, it's nothing but a tuple is nothing but a set of fields, a collection of fields, and those fields can be of any data type, collection of elements. And unlike your Java collections, these need not to be homogeneous data types. It can be heterogeneous data type. This is of string, and this is of integer, and this is of float. Even this is now a tuple, and this is another tuple. All columns with string data type. Now, so this is similar to one single record in a table in SQL terminology. In SQL terminology, you can relate this with, this is one record, right? Like if you assume I have a table called employee with name and some height or weight. Okay, so name, height in centimeters, and weight in kilos. So if that is a table columns, and this is one such record. So one record is treated as a tuple here. And so this here in Pig, the tuple values will be enclosed with parentheses. Okay. Now, so this is one such record in a table, and if you put all those tables together, all those records together, then that table is called as a bag in Pig. So it is nothing but set of records or set of tuples. SQL equivalent is table. Okay, and each tuple can have different set of fields, and a bag can have duplicate tuples also. So duplicate records are allowed. And here in bags, we have again two types. One is an inner bag and another one is an outer bag. So if you have this is one tuple, right? 1, 2, 3 is one tuple. 1, 2, 4 is another tuple. 2, 3, 4 is another tuple. 3, 4, 5 is another tuple. 4, 5, 6 is another. So you have total of 5 records. This collection of 5 records is called as a bag. And if you don't have any curly braces or something, this is called as an outer bag. And within a tuple, if you have a collection of another tuples, like, so this is 1, 2, 3 here, 1, 2, 3 is a tuple, right? And 1, 2, 4 is another tuple. Now, if you take this is again another set of tuples. So what did I define? Set of tuples. Set of tuples is again called as an inner bag. Set of tuples is always a bag anyway. And since this is inside another tuple, now this is enclosed with curly brace. So this is called as inner bag. And here 2, 3, 4 is another tuple, and that one single tuple is present in the bag. That is an inner bag. Okay. So inner bags correlating with SQL tables might make it a bit complex to understand, but your outer bags you can exactly correlate with your SQL tables. This is with 3 columns table. Okay, so those two are the complex data types that we see here. And one more to that list is maps. Same as your Java collections maps, these are nothing but key value pairs. And here the key values are separated by hash. So that is one rule, one point that you have to remember. And one more thing is keys should be always strings. No other data types can be taken as strings. Here name is a string, height is a string, weight is a string. The keys needs to be always strings. That means in Pig terminology, it's a char array data type. And keys must be unique. So if you take in this one row, the name, height, and weight, they are repeated only once. Okay, and these map values are enclosed in square braces. For tuples, this is a tuple, like, okay, name like Murali, and ID is 1001, and age is 32, okay, and salary like 50,000. This is like a tuple. This is as good as like employee table with name which is of char array, comma, ID which is of int, and age which is of int, and salary, it could be of long or something. So this is a tuple, and tuple fields are enclosed in parentheses. If you have such records, set of such records, then this is a bag. And somewhere if you have inside of your data, like key value pairs separated by hash and keys as a string, and value can be of any data type, then that can be taken as your map. Okay, we'll see those examples for each of these data sets. My God, it's even more slower than that. Something happened. I might need to restart my laptop once. Maybe the problem. Okay. So I will load those data sets. So Siva, clear the temp file is option before restart of my VM or Windows. My Windows system, right? Yeah. So it's not the problem with Windows. It's problem with this this Linux. Yeah, I will do that. Okay. Thanks for suggestion. Anyway. Okay. So this is my 5.5 VM. Where is the terminal? It's not yet loaded. Yeah. It's even more slower. Yeah, but let me see at least if the pig is working here or not. So yeah, let's get continued, and we can practice all of them in one go there. Yeah. So once you load any data set, let's say if you want to access those fields, so if I have f1 int, and let's not talk about this complex data type. So if you have this, I will show you there itself. If I have this, if I want to access this field and print there, so here in SQL, we have this. This is like a table, right? I mean, this is almost like a table in SQL. Now, if I want to select only this Murali and age, only the name column. Okay, so here instead of Murali, I will write Anand. And this is where Satish. Here we write Ramesh. Okay. So this is 35 versus 36. I'm interested only in two columns. Now, how will you write in SQL? This is like select name, comma, age from employee. That's it. The same stuff we specify here for each employee. So for every record in employee, generate. This is more like a English kind of language. For every record in employee, generate name, comma, age. So for each with generate, it always like, I mean, for each with generate combination is used like alternative for your select class. I selected two columns. And suppose here if you have select star, here we have generate all. Then all the columns will be extracted. Okay, so that way. Now, what if I didn't provide the names here? How can I access them? So I use the delimiter using the pig storage. Then either you can access them by positional notation. So suppose along with this name, comma, age, I want to access the salary also, but I don't want to use that name. For something, dollar. This is $0, $1, $2, $3. That's it. Okay. And how to access the complex data type fields? Do you want me to share my screen to show that example? Let me see whether I can run it on my machine last time. So give me some time. Yeah. So I will show the examples here in my machine itself. So this way, either by name or by positional notation, you can access your fields. If they are of primitive types, if they are of complex types, then we'll see how to access them. First, we'll see how to declare them in the syntax, then we'll see them. I will kill all other services apart from HDFS and YARN. Then I will see. Okay. So I don't need all these bootstrap 5059 and 2966 REST server. I don't need 417. I don't need, and I don't need 2523, and I don't need two run jars. What are they? 3145 and 3086 also. I will not run. And H region, I don't want the HBase also for now. H region server and 533. Let me see. So quorum peer main and 2882 followed by 5318. Sudo kill -9. Okay. Now it should load a bit faster. Yes, I have big examples here as well. I might have faced the same issue there. Okay. So Hadoop FS -ls. Yeah, at least it is better now. Okay. So a bit faster than that. So I killed those services. I have this data folder here, and I might be having that. So let's see these stuff. Like, so what are the various ways? So all those commands that we have discussed so far. A equal to load and give the path here using big storage. So what if I don't give any delimiter, anything? This is the basic load command that I can run. Okay. So I have submitted that. And again, I loaded that into another relation, another bag. We call this as databag.txt. So this time I specify the comma as delimiter. That's it. Now I use C relation and as F1 comma F2 comma F3. Okay. Now fourth one I declare it as with D and F1 colon. The first field is of integer, second field is also of integer, this one is also of integer. So these are the four ways that I can declare here, right? So if I describe A, unknown schema, describe B, unknown schema, describe C, it displays the schema. I have the column names F1, F2 and F3 and the data types are byte array, byte array, byte array. So it's taking as a arrays of bytes if you don't specify any data type by default. And if you see dump D, so it displays the proper schema. And as part of best practices, this is the syntax always you should prefer. Okay. Now, if I dump A, let's see. So how much time? It's creating that MapReduce jar on its own and submitting that to Yarn, and it's getting submitted there. Okay. Let me see if I can kill any more services. Sudo GPS. I have only Drift server running. Sudo GPS -lm. -lm is for long messages. Okay. So this is run jar is for pig, and this history server is also running for Spark history server. I don't want that. I will kill that 4196 also. And this is HBase Thrift server. I don't want that as well. Okay. So sudo kill -9. I don't want any Spark to be running right now. Okay. And I don't want HBase also to be available for now. And secondary name node, journal node, data node, job history server, and name node. All others are needed. Okay. Yep, all are gone. So it printed. So whatever the data that you have here, so here 1, 2, 3 are here. 1, 2, 3, 1, 2, 3 is here. If you see in the output, so always your output one record is treated as one tuple set of fields, right? This is one tuple, and the set of tuples here is nothing but it's a bag. So what did you printed? You printed A. You printed dump A. Okay. So it printed as it is, but here this you should not take this as a 3 fields, but you don't specify that as 3 fields. You specified it as only one column there. 1, 2, 3 itself is one column with string or a kind of entire line is one field. Okay. So each record is a tuple and set of records is a bag here. So output is a bag. That's why we call A also as a here in this statement. A can be called as a bag. Always your result of your pig functions or pig commands will be a bag set of records. We also call this as a relation. Okay. Now, if I want to extract, describe B, right? Describe B, I have schema is unknown, but I specified the delimiters, right? And let's say I have a relation E, and for each A, generate dollar. If there are more than one field, then I should be able to access $1. Then let's see what will happen if I have this dump E. So $1 column itself is not there. So that's why I printed the space there. Okay. Whereas if I use $0, then I will get complete. Okay. Complete record. So that means that treated as one record, one column itself. And coming to here, so till here I think we have seen the messages. And to understand these statistics, so it prints what is the Hadoop version, what is the peak version you are using, and when was it started and when it finished, and some of the job statistics here, like, so how many, what is your job ID, how many maps, one map task, and there are no reducers, and it's a map only task, and this is the temporary output directories. This outputs, so temporarily it writes into some HDFS location and it displays them on the console. Okay, and in the inputs it successfully read 7 records and successfully stored 7 records into your HDFS temp directory. From there it is showing you the values here. Total records written 7 and all this stuff, information. So this success denotes that your big job is successful. Okay, now, so coming to the B, whereas B is, let me clear the screen. So this is our B statement, right? This is our B statement. I specified the delimiters, but not the column names. Now still I can access the columns there. For each, instead of A, I will go for B and I will print the third column, $2. And dump, it should print me only the third column. Okay, so only the third column is printed. Third column is 3344566. Same 3344566. And similarly, if you want to go by names, you can do that. Okay, so you can practice that. You can select 2 fields at a time. Now, so that is with basic data types. So how should I load the complex data types, the nested schema? Let's say I have data of this type. So some nested schema. So this is of primitive types like 1, 2, 3, 4. I can specify this field name here. And this is of like a inner bag. Curly brace means inner bag. Inside that, it's a set of tuples. And you can specify here. This is complex data types. You have 3 columns in your table. So one is of this basic type. The basic data types obviously you can handle. You have seen ID, name kind of stuff. And this is some complex data type. Table inside a table kind of stuff. And this is a key value pair being used in, or your JSON kind of columns you can specify here. So if you are from Oracle or some Postgres background, so you can have some column data types as JSON, right? And JSON, you can provide any key value pairs there. So for that purpose, you can use the map data type. So this way you can represent here and store them. So let's see nested hyphen schema.txt. Let's load that syntax here. F equal to ideally we should give some meaningful names to these aliases, not A, B, C, D, E. Okay. So like input equal to load, it's present in /user /cloudera /data /nested hyphen schema.txt using pig storage. Pig storage, what is the delimiter there? I think it's tab. There, tab delimiter. Okay. So tab delimiter as, so first field F1 is of type integer and F2 for complex data types we use back, curly brace. Now inside this I have T1 which is of tuple type, which is of, so bag is a collection of the tuples T1s, and inside each tuple how many fields I have? N1 which is of int and N2 which is of int. So this is like a one column as a table. Again it can have, and not this one. So that's F2 is done. F3 is map of this way. So error line 8 column 0 mismatched input expecting, let me use load path using pig storage /t as F1. Here I have this matching. Yep. Yeah. So this input is treated as some kind of keyword. Okay, so that's why it's throwing that error message. Now, if I want to access only this names, okay, so how can I access with that for each generate? So names equal to for each input 1, generate F3 hash name, I think. Okay. F3 hash name. Okay. F3 has your key value, and F3 has, if you want to access separate, it has a separate field. And if you want to access F2, like only this the first column of this table. So 1, 2, 3, 4 and 2, 4, 6, 4. I can specify this way, dot F2 dot tuple dot N1. Okay. Let me specify that. F2 dot T1 will print the tuple dot N1. Let me see what will happen. Error, cannot find field T1 in tuple. T1 in N1 and N2. So I don't need to give tuple. So just directly I can access this N1 and N2 because this is of tuple type. So okay, now if I dump names, so it's not just the names, name followed by the first column followed by the age. So it should print me the okay. So names, all names are extracted, and the first column 1, 2, 3, 4 and 2, 4, 6, 4, and this age is also extracted. These are like 3 columns now. Okay, so that is how you can access your complex. Okay, so F2 dot N1 if you want to access that. So from your complex data types, this is the way to access your columns data. And from maps, we use hash. Okay.
Siva,
Yes, Anand.
quick question, couple questions.
Yeah.
There's still a little bit confusion. You know, you created a tuple, but how did we access tuple, or where do we define tuple? That was not clear from your example. I lost there a little bit.
Where did I created the tuple? First, I loaded this file. You understood this?
Yeah, this I understood. Yes. So the 1, 2, 3, 1, 2, 2, 3, that is the tuple one, right? The second column, right?
Yes. This 1, 2 is one tuple, and 2, 3 is one tuple. So set of tuples is nothing but a bag, right? So that's why I put this in curly brace. So for this, I defined the schema at the time of loading itself. So this is my schema. F2, field 2, which is of bag type, and inside this, it's a collection of tuples. And in this I have, in each tuple I have two fields, N1, N2, and each of with integer types. And third field is of a map type, which is a key comma value base, any number of key comma value base. This load statement, it's clear, right? The schema part. Anand?
Shiva, one question.
Yes, Neetu.
This N1 int, it is defining the one bracketed tuple.
Yep. So it's a set of tuples. This is, so N1, you are telling that this curly F2 is of back. Okay. And generally, you don't get data in these formats ever, but I wanted to show all the complex data types also. Okay, here, curly brace represents this is a back. For that, I used F2 colon back. I opened the curly brace. Inside the curly brace, what do I have? Set of tuples. So this is one tuple and this is another tuple. Okay, so I don't need to specify those many number of fields there. It's like a set of tuples. So there are 2 records in that bag. Okay. So tuple, each record is having two columns, N1 and N2.
Okay.
Okay. That way. So
Shiva,
generally, you never get in your input files in these formats. Don't worry. Yeah, I mean, typically speaking, like, so you will never see this kind of inputs, but so that you will be aware how to use complex data types also. I prepared this kind of input to load into that schema. Okay, so mostly you'll get all those CSVs and TSVs tab separated, and your typical text files formats only, and we'll load them as using the primary data types. Okay, so you loaded this data set. Anand, is that clear?
Yeah, but quickly. So you did not refer any tables. Your data itself had a tuple as a data type. You know, I mean, the data itself a tuple.
Yeah, data itself is like this for me.
Oh, I was wondering if you want to refer a table instead of a tuple itself. You know, in that tuple.
Yeah. See, if it is a table, this will be of like this, right? You will have 10 columns. You'll have all those values like this. They are primitive types. Then obviously, I can. I have shown you those ways, like here in this statement. You can specify all your column names and data types. This is with simple data types.
Right, but tuple, you'll define this as tuple. Can we define this as a tuple altogether?
This F1, F2, and F3?
Yeah, together as a tuple.
Yes. That is
and
one
then,
tuple.
Okay.
That is one record. See, in SQL terminology, the basic comparison, basic mapping is that one record equal to one tuple.
Okay.
Set of records is nothing but table, and set of tuples is nothing but bag. That's it. Here, so one instance, one record. So 1, 2, 3, or this value is 3, this value is 5, this value is 7. So 3, 5, 7 is one tuple, and collection of such values is nothing but a bag that gets assigned to D.
Okay. Okay. Fair enough. Can we create views in Hadoop FS?
Here in Pig, views is nothing but creation of another relation. That's it. You transform it and load another bag. That's it. But these are not persistent here. Once you come out of your Pig shell, all these relations will get vanished. Again, you need to. So views concept will not hold good here. And even the tables, these are not persistent ones. There are limitations. I'm not talking about those limitations right now. First, let me introduce what you can do with Pig. Then I will tell you what you cannot and how you can achieve with the subsequent tools in our course. Okay.
Okay.
So we are going incremental basis. Like, okay, with HDFS, we landed into first step. With MapReduce, we landed into second step. And we are going into third level. So we are going higher level by levels. Okay. Whenever I go to the next tools, I will always point out what are the limitations with the previous level and how you are going to achieve that with the next level. I think you got that migration easily from MapReduce to Pig, right? So why
that is correct.
You got the answer why we need to go for Pig.
Yeah.
Okay. So similarly, you will get to know all these things. Okay. So there are some limitations. We'll see.
Easy to build a right?
What is it?
Easy to build a metric here.
Correct.
Yeah.
Okay. So I hope you got it. So after loading this, the nested schema, I just printed. I am interested in accessing the names here. So what are all the name values and what are their ages? And I am interested in the first column of this. So just to showcase how to access the complex data types, that's it. Okay. So it's directly this way. Okay. I printed that. Next. So for now, to give you a quick gist of quick recap of what we discussed. We know how to load. We know how to store. We know how to dump. We know how to access. We know how to specify schema and access fields and select only a few fields. Okay, so this much we learned on this today. Okay, so if I can spend a couple of minutes or 3-4 minutes, I can complete the operators that you can perform so that you can practice till tomorrow. So you can apply all arithmetic operators, same like in your SQL. If you want to get the sum of two columns for every record, for each A, generate F1, F2, F1 plus F2. So this is equivalent to in select in SQL, same like select F1, F2, and F1 plus F2 as third column from your table name. If table name is A, this is. Okay, what I am trying to say is in your for each statements you can apply arithmetic operators. F1 plus F2, sum of these two columns will be resulted in third column, and F1 minus F2, F1 by F2, percentile F2, all these things you can do. Okay, and yes, this logical operators, this makes sense only with your filter conditions. So here, for each generate is for filtering your columns. So if you have F1 to F10 columns, but if you are selecting only for each A, generate only F1, F5. So you are filtering out 8 columns and selecting only 2 columns. This is columns filtering for each generate. With the select clause, you are filtering the columns. If you want to filter the rows, records as well. Here in SQL, we have where condition, where F1 equal to 1. Then only those records with F1 value equal to 1 will be resulted. But in Pig, we have filter command. Filter A by F1 equal to 1. So this is how you filter your records. So sometimes in interview, you may get this question, what is the difference between for each generate and filter? They both are for filtering only, but one filters the columns for each generate, and the second one filters the rows. Only rows, only the records with this. It will not filter the columns. Okay. So this is for selecting only 2 columns, and this is selecting for the records which matches the first field as 1. Now in this filter conditions, so this pig supports you the logical operators. F1 equal to 8 and F2 equal to 8, then only take those records. If either F1 equal to 8 or F2 equal to 8, and not also, or not of this. F1 equal to 8 or not F2 plus F3 greater than F1. And similarly, you can use the comparison operators. For equality checking, same like Java, double equals, one single equal to is always an assignment operator. Since this big open source framework is also written in Java programming language, you see these similarities. Data types similar to your Java, your class names, camel key is similar to your Java standard, and your comparison operators and all these are similar to your Java. Okay, so filter D by F2 less than 9, all these comparison operators. And these relational operators, so we'll discuss this stuff tomorrow. Okay, so basic relational operators and other stuff. Mathematical, these stuff are not needed. Load storers. So except user defined functions, I might be able to complete by tomorrow. And so the remaining stuff will complete it on the next Monday. Okay. So any questions left out? So power cut, that's why you can join, no problem. So Siva, in the first field, we are getting the result file. We are getting the result file as characters like names. We declared as int. Oh, okay. Here, see, in the output, what am I generating? F3 has name. So which is part of my map. F3 means my third field. Inside that, I want to refer these values. That's why I'm getting names. So in my input, this is the first field, but I'm not taking that into output. I'm selecting only F3 column. I'm not selecting F1 column. Did you get that, Narendra? Okay. Yep. Any other questions? See, it will be very simple. If you have basic knowledge on SQL, you can always compare with it. You can do your coding. Some doubt in MapReduce. When can I call you? I have something to run. Call me around 11 or 12. Okay. Okay. Yep. So is the assignment correct? The second assignment I didn't check, Kila. The first one seems to be okay for me. And can you send me the coding samples, like when coding files as it is, source code as it is, so that I can put them in the Google Drive, others can refer that code instead of the images. Okay, so whichever I feel like it's good, I try to put them in the Google Drive so that others can refer that even if they are busy and they are not getting time to practice. Okay, at least they can refer the solutions that way. Okay, so I sent you coding sample for assignment. Yes, Satish, I received that. Okay, so I didn't get a deep dive into that. I think, yeah, we'll check that slowly. Yep. Thanks, everyone. Bye-bye. Let's meet at the same time tomorrow.